Hi guys! Welcome back to another deep exploration into the mysteries of the ancient world. Tonight, we're embarking on a fascinating journey through time, walking in the footsteps of ancient architects, priests, and worshippers as we uncover the secrets of ancient Greek temples. These magnificent structures weren't just buildings. They were sacred spaces that held the very essence of Greek civilization, harboring mysteries that have captivated scholars for centuries. From the mathematical precision of their construction to the hidden chambers that lay beneath their marble floors, from the sacred rituals that took place within their walls to the astronomical alignments that guided their placement, we'll explore every corner of these ancient sanctuaries. We'll discover how these temples served as banks, hospitals, and centers of learning. And we'll unravel the sophisticated engineering techniques that allowed them to stand for millennia. So grab your favorite blanket, settle into your most comfortable spot, and prepare to be transported back over 2,000 years to a world where gods walked among mortals and every stone held sacred meaning. Okay, friends, before you settle in, if you enjoy this kind of deep dive content, then click the like button and don't forget to subscribe. And yes, leave a comment letting me know where you're watching from and what time it is there. I really enjoy seeing where everyone is listening from. Now, dim the lights and turn on the fan, and let's dive into tonight's journey together. The morning sun cast long shadows across the Athenian agora as young Pythias made his way through the bustling marketplace. It was the year 447 BCE, and the Parthenon was nearing completion atop the Acropolis. Pythias was an apprentice stone carver, one of hundreds of craftsmen working on what would become the most famous temple in the ancient world. As he climbed the sacred hill with his tools in hand, he couldn't have imagined that the secrets he was helping to carve into stone would puzzle archaeologists and historians for over 2 millennia. The path up to the Acropolis was already worn smooth by countless feet, workers, priests, pilgrims, and citizens who made this journey daily. Each morning brought new challenges for the construction crews. The logistics alone were staggering, coordinating the delivery of marble blocks weighing several tons each, managing the complex pulley systems that lifted these massive stones into place, and ensuring that hundreds of specialized craftsmen had the materials and space they needed to complete their intricate work. The construction site buzzed with activity from dawn to dusk, filled with the sounds of chisels striking stone, wooden wheels creaking under heavy loads, and the constant chatter of workers communicating in the dozen different dialects represented among the crew. Pythias had been working on the temple for 3 years now, ever since his father, a master stone carver from the island of Paros, had secured him an apprenticeship with one of the project's chief sculptors. In that time, he had learned not just the technical skills of carving marble, but also the deeper significance of every element he helped create. Each flute on the massive columns had to be carved with mathematical precision, following proportions that had been calculated by the architects to create the illusion of perfect straightness when viewed from below. The entablature above his head bore reliefs that told the story of Athens' mythical founding and the glory of its patron goddess, Athena. What fascinated Pius most were the conversations he overheard between the master architects and the priests who supervised the religious aspects of the construction. They spoke of measurements that had to align with the movements of stars, of chambers within the temple that had to be positioned according to ancient traditions passed down through generations of temple builders, and of acoustic calculations that would ensure the goddess could hear the prayers offered within her sacred home. These weren't just builders constructing a shelter, they were creating a bridge between the mortal and divine worlds. The young apprentice had also begun to notice patterns in the construction that went far beyond what was visible to casual observers. The marble blocks weren't simply stacked upon one another, they were connected by an intricate system of bronze and iron clamps, sealed with lead to prevent corrosion, that allowed the entire structure to move slightly during earthquakes without collapsing. The foundation stones were cut and fitted with such precision that not even a knife blade could slip between them. Yet the entire foundation was slightly curved, a subtle dome shape that compensated for the optical illusion that would make a perfectly flat foundation appear to sag in the middle when viewed from a distance. During his lunch breaks, Pythias often explored other parts of the construction site, marveling at the different specialized crews at work. The bronze workers were crafting decorative elements and structural hardware with techniques that had been perfected over generations. These master metalworkers had traveled from workshops across the Greek world, bringing with them closely guarded secrets of alloy composition and casting techniques. Their temporary foundries on the Acropolis produced not just functional hardware, but also intricate decorative elements that would grace the temple's exterior for centuries to come. The bronze casting process itself was a marvel of ancient technology that few outside the craft truly understood. The workers began by creating detailed wax models of the pieces they intended to cast, carving every detail with the same precision that stone carvers brought to marble. These wax models were then encased in specially prepared clay that would serve as molds once the wax was melted out. The composition of this clay was critical. It had to be strong enough to contain molten bronze, while porous enough to allow gases to escape during the casting process. The furnaces used for melting bronze required constant attention and expert management. The fuel, typically charcoal, had to be fed into the furnace at precisely the right rate to maintain the temperatures needed to melt copper and tin into the alloy known as bronze. The proportion of tin to copper was adjusted depending on the intended use of the finished piece. Structural elements required different alloy compositions than decorative details. The master bronze workers could judge the readiness of the molten metal by its color and behavior, knowledge gained through years of experience and passed down through generations of craftsmen. The timing of bronze pours was critical to the success of the casting process. The molten metal had to be poured quickly and smoothly to fill the mold completely before it began to solidify. Multiple workers coordinated their movements to lift heavy crucibles and guide the flow of metal into complex molds. Any hesitation or mistake could result in incomplete castings that would have to be melted down and recast, wasting valuable materials and time. The painters were preparing pigments that would bring vibrant color to the completed sculptures, mixing expensive materials imported from across the known world. Their workshops buzzed with activity as apprentices ground minerals into fine powders, while master painters experimented with different binding agents and application techniques. The preparation of certain colors, particularly the precious blues made from lapis lazuli, required weeks of careful processing to achieve the intensity and durability needed for exterior temple decoration. The importation of pigment materials represented a significant portion of the temple's construction budget and required coordination with traders operating throughout the Mediterranean and beyond. Lapis lazuli came from distant Afghanistan, traveling along trade routes that stretched for thousands of miles. Cinnabar for red pigments was mined in Spain and transported by ship across dangerous waters. Even seemingly common materials like ochre had to meet strict quality standards and were often sourced from specific locations known for producing superior colors. The testing and quality control processes for pigments were as rigorous as those applied to structural materials. Sample patches were painted on test surfaces and exposed to various weather conditions to determine how different formulations would age and fade over time. The painters maintained detailed records of successful formulations, creating what amounted to technical manuals that could guide future maintenance and restoration work. The roof tile makers were creating thousands of precisely shaped clay tiles that would protect the temple from rain while creating the distinctive profile that would be visible from miles away. Their workshops, located in the lower city near sources of suitable clay, operated around the clock to meet the enormous demand for tiles. Each tile had to be shaped to exact specifications to ensure proper fit and weather resistance. The clay preparation process involved careful selection of raw materials, removal of impurities, and mixing with tempering agents that would prevent cracking during drying and firing. The kiln operations required for firing roof tiles were major industrial undertakings that consumed enormous quantities of fuel and required skilled management to achieve uniform results. The temperature had to be carefully controlled throughout the firing process to ensure that tiles achieved the proper hardness and water resistance. Too little heat would result in tiles that would crumble under weather exposure, while too much heat would cause warping and cracking that would make the tiles unusable. The logistics of tile production and delivery required careful coordination with the construction schedule. Tiles had to be produced in the proper quantities and delivered to the construction site at the right time to avoid storage problems and construction delays. The transportation of thousands of fragile clay tiles from workshops in the lower city to the Acropolis required specialized handling techniques and equipment to minimize breakage during transport. The construction of Greek temples was never a simple architectural endeavor. Each temple was a complex symphony of mathematics, astronomy, religion, and engineering. The Parthenon itself embodied the golden ratio, that mystical proportion that the Greeks believed represented divine perfection. Every measurement, from the spacing of the columns to the curvature of the foundation, was calculated with precision that modern architects still struggle to match. The columns weren't perfectly straight. They had a subtle bulge in the middle called entasis, which created an optical illusion of perfect straightness when viewed from a distance. This wasn't accidental. It was the result of sophisticated understanding of human perception and mathematical principles. The mathematical principles underlying temple construction extended far beyond simple proportional relationships. Greek architects understood concepts that wouldn't be formally developed in European mathematics for another 1,000 years. They employed what we now recognize as principles of calculus to calculate the precise curves needed for optical corrections. They used geometric series to determine the spacing of architectural elements. They applied trigonometric relationships to ensure that the angles of roof slopes and pediments created harmonious visual relationships while providing adequate structural strength. The golden ratio, represented by the Greek letter phi, appeared throughout temple design in ways both obvious and subtle. The overall proportions of temple facades followed this ratio, as did the relationships between the heights and widths of individual architectural elements. The spacing between columns was calculated using golden ratio principles to create rhythmic patterns that the human eye found naturally pleasing. Even the proportions of individual sculptural elements were governed by these mathematical relationships, ensuring that every detail contributed to the overall harmony of the design. But the mathematical sophistication went beyond aesthetic considerations. Greek architects understood principles of structural mechanics that allowed them to build with materials pushed to their limits while maintaining adequate safety margins. They calculated the load-bearing capacity of marble columns and beams using empirical methods developed through generations of construction experience. They understood how different types of stone behaved under various loading conditions and designed accordingly. They recognized the importance of distributing loads evenly throughout the structure and developed techniques for achieving this distribution. The tools used for these calculations were remarkably simple by modern standards, yet they achieved extraordinary precision. Architects used compass and straightedge for geometric constructions, water levels for ensuring horizontal surfaces, and plumb lines for vertical alignment. They developed specialized measuring rods calibrated to the specific proportional systems used in temple design. They created templates and patterns that could be replicated by craftsmen working on different parts of the building. These tools, combined with sophisticated mathematical understanding, allowed ancient architects to achieve accuracy that rivals modern computer-aided design systems. The development and refinement of architectural tools represented a continuous process of innovation driven by the demands of temple construction. Master carpenters created specialized measuring devices that could be used to check the accuracy of curved surfaces and complex angles. Stonemasons developed gauges that ensured consistent dimensions across multiple work sites. Metalworkers produced precision instruments that could be used to verify the alignment and positioning of structural elements with tolerances measured in fractions of inches. The training required for craftsmen to use these tools effectively involved lengthy apprenticeships that combined practical experience with theoretical understanding. Young apprentices learned not just how to use the tools, but also the mathematical principles that governed their application. They studied the proportional systems that determined architectural relationships and learned to recognize when measurements were accurate or when adjustments were needed. The maintenance and calibration of precision tools was an ongoing concern that required specialized knowledge and careful attention. Wooden tools had to be protected from moisture and temperature changes that could cause warping or dimensional changes. Metal tools required regular cleaning and protection from corrosion. The accuracy of measuring devices was checked periodically against master standards to ensure that accumulated wear and environmental effects hadn't compromised their precision. The coordination between different crafts required standardized tools and measurement systems that could be understood and used by all members of the construction team. This standardization process involved not just the physical tools themselves, but also the units of measurement, the symbols used for marking dimensions, and the procedures for checking and verifying accuracy. The development of these standards represented a significant achievement in project management and quality control. The documentation systems used to record measurements and dimensions created permanent records that could be consulted throughout the construction process and during later maintenance activities. These records included not just basic dimensions, but also information about tolerances, material specifications, and assembly procedures. The systematic maintenance of construction records represented an early form of technical documentation that provided valuable guidance for future builders and repairers. The quality assurance processes built around tool use ensured that dimensional accuracy was maintained throughout the construction process. Master craftsmen regularly inspected work in progress using calibrated tools to verify that specifications were being met. Discrepancies were identified and corrected before they could compound into larger problems. The systematic use of precision tools for quality control represented a sophisticated approach to construction management that ensured the structural integrity and aesthetic quality of the finished temple. The influence of temple construction tools extended beyond the building industry to other crafts and trades that required precision measurement and dimensional control. The techniques developed for temple construction influenced shipbuilding, where accuracy was essential for creating vessels that were both seaworthy and efficient. Military engineering adopted temple construction methods for building fortifications and siege equipment that required structural reliability under extreme conditions. The preservation and transmission of tool-making knowledge ensured that the capabilities developed for temple construction were not lost when individual projects were completed. Master toolmakers established workshops that continued to produce precision instruments long after the temples they were originally created for were finished. The techniques and knowledge developed in these workshops were passed down through generations of craftsmen, contributing to the continued advancement of building technology throughout the ancient world. But the mathematical precision was just the beginning of the temple's mysteries. Hidden within the structure were chambers and passages that served purposes far beyond simple worship. Beneath the main floor of many Greek temples lay treasuries where city-states stored their wealth. The Parthenon alone contained what would be equivalent to billions of dollars in today's currency, stored in specially designed chambers that were both secure and accessible to authorized officials. These underground spaces were marvels of engineering, with elaborate drainage systems to prevent water damage and carefully controlled ventilation to maintain optimal conditions for the precious metals and artworks stored within. The treasury chambers represented some of the most sophisticated security engineering in the ancient world. Access was controlled through multiple systems of locks, keys, and physical barriers. Some treasuries employed rotating stone mechanisms that required specific sequences of operations to open. Others incorporated false chambers and hidden passages designed to confuse potential thieves. The most secure treasuries required the presence of multiple officials with different keys or knowledge to gain access, an early form of what modern security experts call multi-factor authentication. The environmental controls in these underground chambers were remarkably advanced. Ventilation systems drew fresh air through carefully designed channels while preventing the entry of moisture that could damage stored materials. Temperature was regulated through the thermal mass of the surrounding earth and stone, creating stable conditions year-round. Some chambers incorporated primitive but effective humidity control systems using hygroscopic materials that absorbed excess moisture from the air. These environmental controls were essential for preserving not just precious metals, but also the papyrus documents, wooden objects, and textile materials that formed part of temple treasuries. The accounting and inventory systems associated with temple treasuries were among the most sophisticated record-keeping systems in the ancient world. Detailed inventories were maintained on stone tablets and papyrus scrolls, documenting not just the quantity and type of stored materials, but also their source, date of deposit, and intended use. These records were often duplicated and stored in separate locations to prevent loss. The precision of these accounting systems has provided modern historians with invaluable insights into ancient economic systems and the wealth of Greek city-states. Some temple treasuries served functions that went beyond simple storage. They operated as banks, lending money to individuals and governments at interest. They provided currency exchange services for international traders. They authenticated precious metals and gemstones, providing certification services that facilitated commerce. They managed investment portfolios on behalf of the temple and the city-state, using the income to fund religious activities and public works. These financial services made temples central to the economic life of their communities and provided them with the resources needed for their elaborate construction and maintenance programs. The security measures protecting these treasuries extended beyond the chambers themselves to encompass the entire temple complex. Guards were stationed at strategic points throughout the site. Alarm systems using mechanical devices and trained animals alerted defenders to intrusions. The layout of temple grounds incorporated defensive features that channeled visitors along predetermined routes while providing clear fields of observation for security personnel. Some temples maintained agreements with neighboring communities for mutual defense, creating networks of protection that extended far beyond individual sites. The guard systems employed at major temples represented sophisticated approaches to security that combined human resources with architectural design and mechanical devices. Guards were typically organized into multiple shifts that provided continuous coverage throughout the day and night. Different guards were assigned to specific areas of responsibility, creating overlapping fields of surveillance that made it difficult for intruders to move undetected. The training of temple guards involved not just physical fitness and combat skills, but also knowledge of the temple layout, security procedures, and emergency response protocols. The communication systems used by temple guards allowed for rapid coordination and response to security threats. Signal systems using horns, bells, or fire beacons could alert guards throughout the complex to potential problems. Message runners maintained contact between different guard posts and could summon additional help from nearby communities if needed. Some temples developed coded communication systems that allowed guards to convey specific information about the nature and location of security threats without alerting potential intruders. The mechanical alarm systems employed in temple security were ingenious devices that used principles of leverage, counterweight, and spring tension to detect unauthorized entry attempts. Tripwires connected to noisemakers could alert guards to movement in restricted areas. Balanced stones or pottery vessels could be dislodged by intruders, creating noise that would draw attention. Some systems used water flow or sand movement to create time-delayed alarms that would continue to sound even if the initial triggering mechanism was discovered and disabled. The use of trained animals in temple security added another layer of protection that was difficult for intruders to anticipate or counter. Guard dogs were trained to patrol specific areas and alert their handlers to the presence of unauthorized persons. Some temples employed geese, which were naturally alert and vocal, as an early warning system that could detect intruders approaching during hours when human guards might be less vigilant. The care and training of security animals required specialized knowledge and represented a significant ongoing expense for temple administrations. The architectural design features that supported temple security were integrated so seamlessly with the overall design that they were often invisible to casual observers. Walls and barriers were positioned to control access routes while appearing to be purely aesthetic elements. Observation points were disguised as decorative features that provided clear sight lines for guards. Storage areas for weapons and emergency supplies were hidden within the architectural fabric of the building. Emergency escape routes allowed defenders to move unseen between different parts of the complex. The legal frameworks governing temple security defined the authority of guards and the penalties for various types of violations. Temple guards were often granted police powers that allowed them to detain suspects and conduct investigations. The laws protecting temple property typically imposed severe penalties for theft or vandalism, reflecting the sacred nature of these sites and the importance of maintaining public confidence in their security. Some temples enjoyed special legal status that extended their protective authority beyond the immediate temple grounds. The coordination between temple security forces and civil authorities created comprehensive protection networks that could respond to various types of threats. Local military units could be called upon to assist with major security incidents that exceeded the capabilities of temple guards. Civil courts handled the prosecution of individuals caught violating temple security, ensuring that violations were punished according to established legal procedures. Intelligence networks shared information about potential threats and suspicious activities that might affect temple security. The economic costs of maintaining comprehensive temple security systems represented significant ongoing expenses that had to be balanced against other temple needs. Guard salaries, equipment maintenance, animal care, and facility upkeep required substantial resources. The cost-benefit analysis of different security measures influenced decisions about which protective systems to implement and maintain. Some temples developed revenue-generating activities specifically to fund their security operations, recognizing that protection of temple treasuries was essential to their continued financial viability. The international aspects of temple security became increasingly important as Greek civilization expanded and temples accumulated wealth from diverse sources. Diplomatic agreements sometimes included provisions for mutual assistance in recovering stolen temple property. International networks of temples shared information about security threats and successful protective measures. The reputation of individual temples for effective security influenced their ability to attract deposits and investments from individuals and governments throughout the Greek world. The acoustic properties of Greek temples were another carefully planned element that most visitors today never fully appreciate. The architects designed these spaces with such precision that a whisper spoken at the altar could be heard clearly at the back of the temple. This wasn't merely for practical purposes, it was deeply connected to the religious experience. When priests performed rituals and spoke the sacred words, every syllable was meant to reach every worshiper with crystal clarity. The curved surfaces of the walls and the specific angles of the roof were all calculated to create what acousticians now recognize as nearly perfect sound environments. The science behind temple acoustics involved principles that wouldn't be formally understood until the development of modern acoustic theory. Greek architects understood that sound waves behaved predictably when they encountered different surfaces and shapes. They recognized that hard surfaces, like marble, reflected sound, while softer materials absorbed it. They knew that curved surfaces could focus sound waves, while angular surfaces could scatter them. They applied this knowledge to create acoustic environments tailored to specific purposes. Different areas within temples had different acoustic characteristics designed for their intended uses. The main sanctuary, where priests delivered important pronouncements, was designed to amplify and clarify speech. Side chambers used for smaller gatherings had more intimate acoustic properties that facilitated conversation and discussion. Underground areas, where mystery rites were sometimes performed, had acoustic characteristics that created otherworldly effects, with whispers seeming to come from nowhere and voices taking on ethereal qualities. The acoustic design process involved careful coordination between architects, craftsmen, and religious officials. Scale models were sometimes constructed to test acoustic properties before final construction. The positioning of columns, the shape of wall surfaces, and the angle of roof elements were all adjusted based on acoustic considerations. Even the choice of materials was influenced by their acoustic properties, with different types of marble and stone selected for their sound reflection characteristics. Some temples incorporated specific acoustic features designed to create dramatic effects during religious ceremonies. Echo chambers amplified the voices of priests or created mysterious repetitions of sacred words. Resonance chambers enhanced the sound of musical instruments or created harmonic overtones that added emotional impact to rituals. Whispering galleries allowed confidential communications between priests or created the illusion that the gods themselves were speaking directly to worshippers. The acoustic properties of temples also served practical administrative functions. In temples that served as meeting places for civic assemblies, the acoustic design ensured that speakers could address large crowds effectively. The sound quality in these spaces influenced the development of oratorical techniques and contributed to the Greek tradition of public speaking and debate. The acoustic excellence of temple spaces made them preferred venues for musical and dramatic performances, contributing to the development of Greek theater and musical traditions. Modern acoustic analysis of surviving Greek temples has revealed sophisticated understanding of complex acoustic phenomena. Computer modeling has shown that the acoustic properties of temples like the Theater of Epidaurus involve precise mathematical relationships between architectural dimensions and sound wavelengths. The acoustic design of these spaces represents an integration of empirical observation, mathematical calculation, and artistic sensibility that modern architects strive to emulate. The scientific principles underlying ancient Greek acoustic design have become clearer through the application of modern acoustic measurement and analysis techniques. Researchers have discovered that the Greeks understood concepts that wouldn't be formally developed in acoustic theory for many centuries. They recognized that sound waves have specific wavelengths that interact predictably with architectural features of corresponding dimensions. They understood that the human ear responds differently to various frequencies, and that architectural spaces could be designed to enhance or suppress specific types of sounds. The experimental methods used by ancient architects to develop acoustic designs likely involved extensive testing and refinement over many generations of temple construction. Master builders would have observed how different architectural configurations affected sound quality and gradually refined their understanding of the principles involved. The knowledge gained from each project would have been passed down to subsequent generations of architects, creating a cumulative body of expertise that informed increasingly sophisticated designs. The relationship between acoustic design and construction materials was another area where ancient architects demonstrated remarkable understanding. They recognized that different types of stone had different sound reflection and absorption properties. Marble, with its hard, smooth surface, provided excellent sound reflection that could be used to project voices across large spaces. Softer stones absorbed more sound energy, creating more intimate acoustic environments. The selection of materials for different parts of a temple was influenced by both structural requirements and acoustic considerations. The integration of acoustic principles with other aspects of temple design required careful coordination and sophisticated understanding of multiple engineering disciplines. The structural requirements for supporting massive stone roofs had to be balanced with acoustic needs for specific interior volumes and surface configurations. The aesthetic goals for visual harmony and proportional relationships had to be reconciled with acoustic requirements for optimal sound quality. The religious requirements for specific ritual activities had to be accommodated within architectural spaces that also provided excellent acoustic environments. The maintenance of acoustic properties over time required ongoing attention to factors that could affect sound quality in temple spaces. The accumulation of soot from oil lamps and incense could change the surface characteristics of walls and ceilings, altering their acoustic properties. Structural settling or earthquake damage could shift architectural elements enough to affect acoustic performance. The replacement of worn or damaged architectural components had to maintain the original acoustic design to preserve sound quality. The influence of temple acoustic design extended to other types of buildings throughout the ancient world. The theaters for which Greek architecture is famous incorporated acoustic principles that were first developed in temple construction. Public buildings such as council chambers and law courts adopted acoustic design features that ensured effective communication in civic settings. Private buildings sometimes incorporated acoustic elements that enhanced the comfort and functionality of domestic spaces. The documentation and preservation of acoustic design knowledge was essential for maintaining the quality of temple construction over extended periods. Master architects maintained records of successful acoustic configurations that could be referenced in future projects. Apprentice architects learned acoustic principles through hands-on experience with existing buildings as well as theoretical instruction. The systematic study of acoustic phenomena contributed to the development of architectural theory and the advancement of building technology. The training programs developed for architectural apprentices included extensive instruction in acoustic principles and their practical application. Young architects learned to recognize the acoustic characteristics of different architectural configurations through guided observation of existing buildings. They practiced acoustic design through the creation of scale models that demonstrated how sound waves behaved in different spatial arrangements. The combination of theoretical knowledge and practical experience produced architects who could design buildings with sophisticated acoustic properties. The tools and techniques used for acoustic analysis in ancient times were necessarily different from modern electronic instruments, but they were effective within their limitations. Architects used their own voices and hearing to test acoustic properties during construction, making adjustments based on direct observation of sound quality. Musical instruments were sometimes used to test how spaces would perform for different types of acoustic events. The positioning of temporary sound sources allowed architects to evaluate acoustic properties before final construction decisions were made. The standardization of acoustic design principles across different temple projects created consistency in acoustic quality that enhanced the reputation of Greek temple architecture throughout the ancient world. Temples built in different locations using similar acoustic design principles provided comparable worship experiences for visitors familiar with other Greek temples. This standardization also facilitated the training of architects and craftsmen, as acoustic knowledge developed at one site could be readily applied to projects in other locations. The adaptation of acoustic design principles to different local conditions required flexibility and creativity on the part of temple architects. Variations in local building materials necessitated adjustments to acoustic design to achieve desired sound quality. Different climatic conditions affected how sound traveled and how materials performed acoustically. Local cultural preferences for different types of acoustic environments influenced design decisions while maintaining overall Greek architectural traditions. The economic implications of acoustic design were significant factors in temple construction planning and budgeting. The additional time and materials required for sophisticated acoustic design represented substantial investments that had to be justified by the benefits they provided. The enhanced reputation and increased visitor appeal of temples with excellent acoustic properties could generate additional revenue that offset the costs of acoustic design. The long-term benefits of acoustic excellence often justified the initial investment through improved functionality and prestige. The relationship between acoustic design and religious practice was fundamental to the success of temple architecture. The acoustic properties of temple spaces had to support the specific types of religious activities that would take place within them. Ceremonial speaking required acoustic environments that projected voices clearly to all participants. Musical performances needed spaces with appropriate reverberation characteristics. Contemplative activities benefited from acoustic environments that minimized distracting external noise while maintaining pleasant ambient sound qualities. The collaborative aspects of acoustic design brought together architects, religious officials, and acoustic specialists in interdisciplinary teams that combined different types of expertise. Religious officials provided guidance on the types of acoustic environments needed for different ceremonial activities. Acoustic specialists contributed technical knowledge about sound behavior and design techniques. Architects integrated acoustic requirements with structural, aesthetic, and functional considerations to create comprehensive design solutions. The testing and validation of acoustic design involved extensive evaluation during construction to ensure that theoretical predictions matched actual performance. Temporary installations allowed acoustic testing before final construction commitments were made. Adjustments could be made to architectural elements based on acoustic testing results. The iterative process of testing and refinement ensured that finished temples provided the acoustic performance intended by their designers. The documentation of acoustic design solutions created valuable resources for future temple projects and contributed to the advancement of architectural knowledge. Detailed records of successful acoustic configurations provided templates for similar projects in other locations. Analysis of acoustic failures and problems informed improvements in design techniques and construction methods. The systematic accumulation of acoustic design knowledge contributed to the continuous improvement of temple architecture over time. The modern study of ancient acoustic design has contributed to contemporary understanding of architectural acoustics and has influenced the design of modern performance spaces. Computer analysis of ancient theaters and temples has revealed design principles that are still relevant for contemporary acoustic engineering. The integration of aesthetic and functional considerations pioneered in ancient temple design continues to influence modern architects working on projects that require both visual beauty and acoustic excellence. The psychological and emotional effects of acoustic design in temple spaces were carefully considered by ancient architects. They understood that sound quality could influence the emotional state of worshipers and enhance the spiritual impact of religious ceremonies. The acoustic properties of temple spaces were designed to create feelings of awe, reverence, and connection with the divine. The careful orchestration of acoustic effects contributed to the overall religious experience and reinforced the sacred nature of temple spaces. Archaeological evidence suggests that many temples incorporated sophisticated timing mechanisms and astronomical observation devices. The Temple of Apollo at Delphi, for instance, was positioned so that during certain times of the year, sunlight would enter the inner sanctum at precisely the moment when oracular pronouncements were made. This created a dramatic effect that reinforced the divine nature of the prophecies. Modern analysis has revealed that the temple's orientation and the positioning of openings in the roof were calculated with astronomical precision that required detailed knowledge of celestial movements. The integration of astronomical observations into temple design represented one of the most sophisticated aspects of ancient Greek architecture. These alignments weren't simply decorative or symbolic. They served practical functions in the religious calendar and demonstrated the priest's mastery of complex mathematical and observational skills. The calculation of these alignments required detailed knowledge of the apparent motions of the sun, moon, planets, and stars throughout the year, as well as understanding of the long-term cycles that governed celestial phenomena. Many temples incorporated features that functioned as primitive but effective astronomical instruments. Shadow-casting elements allowed priests to track the passage of time throughout the day and determine the exact moments for specific rituals. Window and door openings were positioned to frame particular stars or constellations at significant times. Some temples included specially designed chambers where the interplay of sunlight and shadow created calendrical displays that tracked the progress of the seasons with remarkable accuracy. The Temple of Apollo at Bassae in Arcadia provides one of the most striking examples of astronomical alignment in Greek temple architecture. The temple is oriented so that its main axis points toward the rising point of the star Arcturus, which was associated with Apollo in Greek mythology. But the alignment is even more sophisticated than simple stellar orientation. The temple's design incorporates features that track the star's movement throughout the night and across the seasons. Interior chambers are positioned so that Arcturus appears in specific locations at particular times of year, creating a three-dimensional astronomical calendar that guided religious observances. The famous oracle at Delphi incorporated multiple astronomical elements into its operations. The temple's orientation was calculated to maximize dramatic lighting effects during oracular sessions. The sacred vapors that inspired the Pythia were believed to be strongest when certain celestial conditions were met. The timing of major oracular pronouncements was coordinated with astronomical events that reinforced their divine authority. Modern geological and astronomical analysis has revealed that these alignments were based on sophisticated understanding of both celestial mechanics and local geological phenomena. The Parthenon itself embodies astronomical principles in ways that are still being discovered by researchers. The temple's orientation relates to the rising of specific stars associated with Athena. The positioning of sculptural elements creates shadow patterns that track important dates in the Athenian religious calendar. The mathematical relationships governing the temple's proportions correspond to astronomical cycles, creating a structure that functions as a massive three-dimensional representation of cosmic harmony. The priests who managed these astronomical systems possessed knowledge that rivaled that of professional astronomers in later periods. They maintained detailed observational records spanning generations, tracking long-term patterns in celestial movements. They developed predictive models that allowed them to forecast eclipses, planetary positions, and other astronomical events years in advance. This knowledge gave them enormous prestige and influence in ancient society, as the ability to predict celestial phenomena was seen as evidence of divine favor and wisdom. The astronomical knowledge preserved in temple traditions contributed to the development of Greek mathematical and scientific thinking. Many of the geometric principles used in temple design were directly derived from astronomical observations. The mathematical techniques developed for calculating celestial alignments influenced other fields of Greek mathematics. The observational methods used in temple astronomy provided foundations for later developments in scientific methodology. The observational astronomy practiced by temple priests represented one of the most sophisticated scientific activities in the ancient world. These observations required patience, precision, and mathematical sophistication that few individuals possessed. The priests maintained detailed records of celestial phenomena over many years, tracking patterns and cycles that weren't obvious from short-term observations. The accuracy of their observations has been confirmed by modern astronomical calculations, demonstrating the high level of scientific competence achieved in temple astronomy. The instruments used for astronomical observation in temple contexts were carefully designed tools that maximized accuracy within the constraints of available technology. Shadow casting devices called gnomons allowed precise measurement of the sun's position throughout the day and across the seasons. Star charts and celestial maps recorded the positions and movements of important stars and constellations. Water clocks and other timekeeping devices provided accurate measurement of time intervals needed for astronomical calculations. The mathematical methods used for astronomical calculations involve sophisticated geometric and arithmetic techniques. The priests developed methods for predicting eclipses years in advance using mathematical models of celestial motions. They calculated the positions of planets and stars for specific dates and times. They determined the precise times of solstices, equinoxes, and other astronomically significant events. These calculations required mathematical sophistication that rivaled the work of professional astronomers in later periods. The integration of astronomical knowledge with religious practice created powerful combinations of scientific observation and spiritual significance. The timing of religious ceremonies was coordinated with astronomically determined dates that reinforced their sacred importance. The interpretation of celestial events as divine communications required both technical understanding of astronomy and deep knowledge of religious traditions. The ability to predict astronomical events enhanced the prestige and authority of temple priests in ancient society. The preservation and transmission of astronomical knowledge across generations required systematic educational programs and careful documentation. Young priests learned astronomical techniques through apprenticeship programs that combined theoretical instruction with hands-on observation experience. Written records of astronomical observations and calculations were maintained in temple libraries and archives. The knowledge accumulated over many generations created astronomical traditions that represented some of the most advanced scientific achievements of the ancient world. The application of astronomical knowledge to practical problems demonstrated the utility of temple-based scientific research. Agricultural planning benefited from accurate seasonal calendars based on astronomical observations. Navigation techniques used astronomical knowledge to determine location and direction during sea voyages. Engineering projects incorporated astronomical alignments that enhanced their symbolic significance and practical functionality. The international exchange of astronomical knowledge created networks of scientific communication that spanned the ancient world. Temple priests corresponded with colleagues at other sites, sharing observations and comparing calculations. Traveling scholars visited different temples to learn about local astronomical traditions and contribute their own knowledge. The cross-pollination of ideas contributed to the advancement of astronomical science throughout the Greek world and beyond. The validation of astronomical predictions through careful observation provided early examples of scientific method and empirical testing. Priests checked their theoretical predictions against actual observations, refining their methods when discrepancies were discovered. The accuracy of astronomical predictions served as a measure of the validity of underlying theoretical models. The systematic approach to testing and validation established precedents for scientific methodology that influenced later developments in natural philosophy. The economic value of astronomical knowledge provided practical benefits that justified the resources invested in temple-based research. Accurate calendars facilitated agricultural planning and trade scheduling. The ability to predict eclipses and other astronomical events attracted visitors and donations to temples. The prestige associated with astronomical expertise enhanced the political influence and economic power of temple establishments throughout the ancient world. The construction techniques themselves held secrets that have only recently been understood. The massive marble blocks that formed the walls and columns were fitted together without mortar, using a complex system of metal clamps and dowels. These metal connectors were often made of iron covered with lead to prevent corrosion, a technique that allowed the structures to flex slightly during earthquakes rather than cracking catastrophically. The Greeks had learned through experience that rigid structures were more likely to fail during seismic events, so they developed building methods that incorporated a degree of flexibility while maintaining structural integrity. The joinery techniques used in Greek temple construction represented the culmination of centuries of architectural experimentation and refinement. Each type of joint was specifically designed for its structural function and the particular stresses it would encounter. Column drums were connected using wooden dowels that allowed for slight movement while preventing displacement. Wall blocks were secured with iron clamps, shaped and positioned to distribute loads evenly while accommodating thermal expansion and contraction. The lead that encased these iron elements wasn't just for corrosion protection, it also provided a cushioning effect that absorbed shock and prevented stress concentrations that could crack the marble. The precision required for these jointing systems was extraordinary. Stone surfaces had to be cut and polished to tolerances measured in fractions of millimeters to ensure proper fit and load distribution. The positioning of clamps and dowels required precise drilling and cutting, with holes that had to align perfectly between adjacent blocks. Master stonemasons developed specialized tools and techniques for achieving this precision, including calibrated measuring devices, precision drilling equipment, and finishing techniques that produced surfaces smoother than many modern machine finishes. The earthquake resistance built into Greek temple construction was based on empirical understanding developed through observation of seismic damage and structural failures. Builders learned that flexible connections between structural elements allowed buildings to absorb earthquake energy without catastrophic failure. They discovered that certain proportions and configurations provided better seismic performance than others. They developed techniques for creating structural systems that could redistribute loads when individual elements were damaged or displaced. The metalworking techniques required for temple construction hardware represented some of the most sophisticated metallurgy in the ancient world. Bronze and iron elements had to be cast, forged, and finished to precise specifications. The lead coating applied to iron clamps required careful temperature control and timing to achieve proper adhesion and thickness. Some temples incorporated bronze elements that were cast in complex shapes that required advanced foundry techniques and pattern-making skills. The tools used in temple construction were themselves marvels of ancient engineering. Lifting devices capable of moving multi-ton stone blocks required sophisticated understanding of mechanical advantage, load distribution, and material science. Cutting and shaping tools had to be manufactured from the best available materials and maintained to extremely high standards. Measuring and layout instruments had to provide accuracy comparable to modern surveying equipment. The development and manufacture of these tools represented significant technological achievements that influenced other areas of ancient industry. The quarrying operations that supplied stone for temple construction were massive industrial undertakings that required careful coordination of labor, equipment, and transportation resources. Quarry masters had to identify stone with the proper characteristics for architectural use, plan extraction sequences that minimized waste, and coordinate the cutting and shaping of blocks to match architectural specifications. The quality control systems used in quarrying ensured that only stone meeting strict standards reached construction sites, preventing delays and ensuring structural integrity. The transportation systems developed for moving quarried stone represented major logistical achievements. Road networks had to be constructed or improved to handle the enormous loads. Special vehicles were designed for transporting stone blocks, including wheeled platforms, rolling systems, and waterborne transport for coastal sites. The coordination of these transportation systems required detailed planning and scheduling to ensure that materials arrived at construction sites when needed, while minimizing handling and storage costs. The quarrying and transportation of the marble presented challenges that required innovative solutions. The Pentelic marble used in the Parthenon was quarried from Mount Pentelicus, about 10 miles northeast of Athens. The blocks, some weighing several tons, had to be cut from the quarry face, shaped to rough specifications, and then transported across difficult terrain. Archaeological investigations have uncovered evidence of sophisticated pulley systems, wooden rollers, and even primitive railways made of stone that facilitated this massive undertaking. The precision required to cut the marble blocks so they would fit together perfectly after transportation was remarkable, requiring master craftsmen who understood both the properties of the stone and the architectural requirements of the final structure. The quarrying process itself was a complex operation that combined skilled craftsmanship with sophisticated engineering. Quarry masters had to identify veins of marble with the proper color, texture, and structural characteristics for architectural use. They developed techniques for following these veins deep into the mountainside while maintaining the quality and consistency needed for building construction. The extraction process required careful planning to minimize waste and ensure that blocks were cut to dimensions that could be efficiently transported and used. The tools used in quarrying ranged from simple hand implements to complex mechanical devices. Bronze and iron wedges were used to split stone along natural fault lines. Specialized saws with abrasive cutting compounds were employed for precise cuts. Lifting equipment included compound pulley systems that could multiply human effort to move massive blocks. The development and maintenance of these tools required skilled craftsmen who understood both metallurgy and stoneworking techniques. The workforce involved in quarrying operations was highly organized and specialized. Master quarrymen supervised the overall operation and made critical decisions about extraction sequences and quality control. Skilled stonecutters performed the precise work of shaping blocks to architectural specifications. Laborers handled the heavy work of moving materials and operating lifting equipment. Support workers maintained tools, prepared cutting materials, and managed the logistics of the operation. The transportation systems developed for moving quarried stone were engineering marvels in their own right. The roads leading from quarries to construction sites had to be built to handle loads far exceeding normal traffic. These roads required careful grading to minimize slopes that would make transportation difficult or dangerous. Bridge structures had to be reinforced to support the passage of heavily loaded vehicles. Way stations were established at regular intervals to provide rest for work crews and maintenance for transportation equipment. The vehicles used for stone transport were specially designed for this purpose. Heavy-duty carts with reinforced wheels and axles could carry blocks weighing several tons. Rolling systems used cylindrical wooden elements to move blocks across level ground. Skid systems with wooden runners allowed blocks to be dragged across rough terrain. For water transport, specially designed barges and loading systems facilitated the movement of stone by river and sea routes. The coordination required for successful stone transport operations involved detailed planning and scheduling. Transportation had to be coordinated with quarrying operations to ensure steady supply without creating bottlenecks. Weather conditions had to be considered, as rain could make roads impassable, and wind could make water transport dangerous. The availability of work crews and draft animals had to be managed to maintain steady progress. Storage facilities at construction sites had to be planned to accommodate materials arriving from multiple quarries on varying schedules. The quality control systems implemented throughout the quarrying and transportation process ensured that only suitable materials reached construction sites. Blocks were inspected at multiple stages for cracks, color variations, and other defects that could affect their suitability for specific architectural purposes. Damaged blocks were either repaired if possible or redirected to uses where their defects would not compromise structural integrity or aesthetic quality. This quality control system was essential for maintaining the high standards expected in temple construction. The environmental impact of quarrying operations was carefully managed to ensure long-term sustainability. Quarry sites were developed in ways that minimized damage to surrounding areas. Waste materials were used for secondary purposes, such as road construction and foundation work. Water sources were protected from contamination by quarrying activities. Exhausted quarry sites were sometimes converted to other uses, such as storage areas or workshops. The economic systems that supported quarrying and transportation operations were complex and far-reaching. Quarry ownership involved various arrangements, including state control, private ownership, and cooperative ventures. Labor was organized through contracts, slavery, and free wage systems. Transportation services were provided by specialized contractors who owned vehicles and equipment. The financing of these operations required significant capital investment and careful management of cash flow to maintain operations over the extended periods required for major construction projects. The contractual arrangements governing quarrying operations established legal frameworks that defined rights, responsibilities, and compensation for all parties involved. Quarry leases specified the terms under which private contractors could extract stone from public lands. Labor contracts defined working conditions, wages, and responsibilities for different categories of workers. Supply agreements established schedules, quality standards, and delivery requirements for stone products. These contractual systems provided stability and predictability that facilitated long-term planning and investment in quarrying operations. The labor management systems used in quarrying operations represented sophisticated approaches to organizing large workforces with diverse skills and backgrounds. Work crews were organized into specialized teams responsible for different aspects of the quarrying process. Skilled stone cutters worked alongside general laborers, with each group having specific responsibilities and compensation levels. Supervisory structures ensured coordination between different work groups and maintained quality standards throughout the operation. The seasonal aspects of quarrying operations required careful planning to maximize productivity while accommodating weather-related constraints. Winter weather often made quarrying difficult or impossible, requiring operations to be concentrated during favorable seasons. Seasonal variations in transportation conditions affected the scheduling of stone delivery to construction sites. The storage of extracted stone during periods when transportation was difficult required careful planning and adequate facilities. The technological innovations developed for quarrying operations contributed to advances in other areas of ancient industry and engineering. Improved cutting techniques found applications in sculpture and architectural decoration. Heavy lifting equipment was adapted for use in other types of construction projects. Transportation innovations influenced the development of military engineering and siege warfare technology. The systematic approach to large-scale material handling developed in quarrying operations provided models for other industrial undertakings. The environmental management practices employed in quarrying operations demonstrated awareness of the need to balance industrial activity with long-term sustainability. Quarry sites were developed in ways that minimized damage to surrounding agricultural land and water sources. Waste materials were used constructively whenever possible, reducing the environmental impact of extraction activities. Exhausted quarry sites were often converted to other uses that provided continued economic value to local communities. The quality assurance systems implemented in quarrying operations ensured that temple construction projects received materials that met the demanding standards required for monumental architecture. Stone was inspected at multiple stages of the quarrying process to identify and reject material with structural flaws or aesthetic defects. Standardized grading systems allowed architects to specify the exact type and quality of stone needed for different parts of their projects. The systematic approach to quality control contributed to the structural integrity and artistic excellence of finished temples. The supply chain management systems coordinating quarrying with construction schedules required sophisticated logistical planning and communication. Quarrying operations had to produce stone in the right quantities and qualities to match construction progress. Transportation had to be coordinated to deliver materials when they were needed while avoiding storage bottlenecks at construction sites. The integration of quarrying, transportation, and construction activities required project management skills that were advanced for their time. The economic impact of quarrying operations extended far beyond the immediate costs and benefits of temple construction projects. Quarrying provided employment for large numbers of skilled and unskilled workers, contributing to local economic development. The demand for quarrying equipment and supplies supported related industries, including metalworking, woodworking, and rope making. The transportation requirements generated business for vehicle manufacturers, road builders, and shipping operators. The international trade aspects of stone quarrying created economic connections that spanned the ancient Mediterranean world. Premium marble from specific quarries was exported to construction projects hundreds of miles away. The reputation of particular quarries for producing superior stone created brand recognition that commanded premium prices in international markets. The coordination of international stone trade required diplomatic agreements, standardized measurement systems, and reliable transportation networks that facilitated broader economic and cultural exchange throughout the ancient world. Within the temples, the placement of every element served multiple purposes. The altar wasn't simply positioned for convenience. Its location was determined by complex calculations involving the temple's orientation, the movement of celestial bodies, and the specific requirements of the deity being honored. In the temple of Athena Parthenos, for example, the massive gold and ivory statue of the goddess was positioned so that during certain festivals, the rising sun would illuminate her face at the exact moment when specific rituals were performed. This required precise knowledge of the sun's path throughout the year and careful coordination between architects and priests. The positioning of cult statues within temples represented one of the most sophisticated aspects of ancient religious architecture. These statues weren't merely decorative elements, they were considered the actual dwelling places of the gods, and their placement required careful consideration of multiple factors. The orientation had to be correct according to religious tradition and astronomical principles. The lighting had to be optimal for both daily worship and special ceremonies. The acoustics had to allow the statue to hear prayers and offerings properly. The sightlines had to ensure that the statue was visible from all appropriate vantage points within the temple. The construction of cult statues like the Athena Parthenos was itself a major undertaking that required coordination with the architectural project. The statue's internal framework had to be constructed before the temple roof was completed to allow for the installation of its massive components. The gold and ivory surfaces required specialized craftsmen with skills in multiple techniques, including metalworking, ivory carving, and gem setting. The statue's clothing and accessories were often removable, allowing for cleaning, repair, and seasonal changes that were part of regular temple maintenance routines. The lighting systems that illuminated cult statues were carefully engineered to create specific visual effects. Natural lighting was controlled through the positioning and sizing of windows, doors, and other openings. Artificial lighting used oil lamps and torches positioned to eliminate shadows and create even illumination. Some statues incorporated reflective elements that caught and redirected light to create dramatic effects. The interplay between statue, lighting, and architectural elements was choreographed to enhance the emotional and spiritual impact of religious encounters. The storage and security systems associated with cult statues reflected their enormous value and sacred significance. Removable decorative elements were stored in specially designed chambers when not in use. Security measures protected these valuable items from theft and damage. Cleaning and maintenance procedures were established to preserve the statue's appearance and structural integrity. Records were maintained documenting the statue's condition, maintenance history, and any changes or repairs that were made over time. The workshops and studios where cult statues were created were temporary but sophisticated industrial facilities. These workshops required specialized equipment for working with precious materials, controlled environments for delicate assembly operations, and security measures to protect valuable work in progress. The coordination between statue workshops and temple construction required careful scheduling to ensure that both projects progressed in proper sequence. The skilled craftsmen who worked on cult statues represented some of the most talented artists and technicians in the ancient world. The religious ceremonies associated with the installation of cult statues were elaborate affairs that marked the completion of temple construction and the beginning of regular worship activities. These ceremonies involved processions, sacrifices, and rituals that formally invited the deity to take up residence in the new temple. The timing of these ceremonies was coordinated with astronomical events and religious calendars. The participation of civic officials, priests, and citizens created community-wide celebrations that reinforced social bonds and religious commitments. The maintenance of cult statues required ongoing attention from specialized craftsmen and religious personnel. Regular cleaning removed dust and soot from burning incense and lamps. Periodic inspections identified damage that required repair. Seasonal ceremonies involved dressing the statue in different clothing or decorations. Major renovations were occasionally necessary to address deterioration or damage from accidents or natural disasters. These maintenance activities were often incorporated into regular religious observances, making practical care of the statue part of ongoing worship practices. The symbolic programs associated with cult statues extended far beyond their basic religious functions. The iconography of the statue conveyed complex theological concepts through visual symbolism. The materials used carried symbolic meanings related to the deity's attributes and powers. The size and scale of the statue expressed the importance of the deity in the local religious hierarchy. The artistic style reflected cultural values and aesthetic preferences that connected the local community to broader Greek traditions. The role of water in temple design was another carefully considered element. Many temples incorporated channels and basins that served both practical and ceremonial purposes. The Temple of Poseidon at Sunion, perched on a cliff overlooking the Aegean Sea, included a complex system of channels that collected rainwater and channeled it to underground cisterns. But these water features also played important roles in religious ceremonies. The sound of flowing water was believed to facilitate communication with the gods, and many rituals involved the ceremonial washing of participants or offerings. The decoration of temples extended far beyond mere ornamentation. The sculptural programs that adorned the pediments, friezes, and metopes told complex stories that served as both artistic expression and religious instruction. The Parthenon's frieze, which depicted the Panathenaic procession, wasn't simply decorative. It was a visual representation of the relationship between the city of Athens and its patron goddess. Every figure, every gesture, every fold of drapery was carefully planned to convey specific meanings to viewers who understood the religious and cultural context. The planning and execution of temple sculptural programs involved extensive collaboration between religious authorities, civic leaders, and artistic teams. The selection of themes and subjects required deep understanding of religious traditions, political considerations, and artistic capabilities. Preliminary designs were often created in smaller formats to allow for review and revision before full-scale carving began. The coordination of sculptural work with architectural construction required careful scheduling to ensure that decorative elements were completed and installed at the proper stages of building construction. The carving techniques used in temple sculpture represented the highest achievements of ancient stoneworking technology. Master sculptors developed specialized tools and techniques for working with marble and other sculptural materials. The creation of large-scale sculptural compositions required understanding of proportion, perspective, and visual relationships that challenged even the most skilled artists. The finishing techniques used to achieve smooth surfaces and fine details required years of training and experience to master. The painting and polychromy applied to temple sculptures added layers of meaning and visual impact that are often overlooked in discussions of ancient art. Careful analysis of paint traces on surviving sculptures has revealed complex color schemes that enhanced the sculptural forms and added symbolic content. Different colors were associated with specific deities, emotions, or concepts, creating additional layers of meaning for viewers familiar with these associations. The application of paint required specialized materials and techniques that were closely guarded trade secrets. The subject matter depicted in temple sculptures served multiple educational and inspirational functions. Mythological scenes provided religious instruction and reinforced cultural values. Historical events celebrated civic achievements and preserved collective memory. Allegorical representations conveyed complex philosophical and theological concepts through visual metaphors. The selection and arrangement of sculptural subjects created comprehensive programs that told interconnected stories spanning multiple surfaces and architectural elements. The viewing experience of temple sculptures was carefully choreographed to guide visitors through progressive revelation of meaning. The positioning of sculptural elements controlled the sequence in which stories were encountered and understood. The relationship between sculpture and architecture created dramatic effects that enhanced emotional impact. The integration of natural and artificial lighting highlighted important details and created changing visual experiences throughout the day. The workshops where temple sculptures were created were sophisticated, artistic, and industrial establishments. These workshops required specialized equipment for stone carving, bronze casting, and other sculptural techniques. The organization of workshop labor involved complex hierarchies of master artists, skilled craftsmen, and apprentices. The coordination between workshops and construction sites required careful scheduling and quality control to ensure that sculptural elements fit properly within architectural settings. The conservation and maintenance of temple sculptures required ongoing attention throughout the life of the temple. Regular cleaning removed accumulated dirt and pollution that could damage sculptural surfaces. Protective measures shielded sculptures from weather damage and human interference. Repair work addressed damage from accidents, vandalism, or natural deterioration. The documentation of sculptural condition and maintenance history provided valuable information for future conservation efforts. The influence of temple sculptural programs extended far beyond their original religious contexts. The artistic innovations developed for temple decoration influenced other forms of sculptural production throughout the ancient world. The technical achievements of temple sculptors contributed to the advancement of stone carving and bronze casting techniques. The aesthetic principles embodied in temple sculptures became standards for artistic excellence that continued to influence Western art for centuries. The colors used in temple decoration were also significant, though most visitors to Greek ruins today see only weathered white marble. In their original state, these temples were vibrant with color. Archaeological analysis has revealed traces of red, blue, gold, and other pigments that once brought the sculptures and architectural elements to life. The choice of colors wasn't arbitrary. Specific hues were associated with particular deities and had symbolic meanings that enhanced the religious experience of visitors. The production and application of pigments for temple decoration involved sophisticated chemical knowledge and artistic techniques. The creation of durable colors required understanding of mineral properties, chemical reactions, and environmental effects that could cause fading or deterioration. Red pigments were often derived from cinnabar or red ochre, blue from lapis lazuli or Egyptian blue, and gold from actual gold leaf applied over carefully prepared surfaces. The preparation of these pigments involved grinding, mixing, and processing techniques that were closely guarded trade secrets. The symbolic significance of colors in Greek religious contexts added layers of meaning to temple decoration that modern viewers often miss. Red was associated with blood, sacrifice, and divine power. Blue represented the heavens, water, and divine wisdom. Gold symbolized divine light, immortality, and supreme value. White indicated purity, truth, and divine presence. The careful selection and placement of colors created visual hierarchies that guided viewers' understanding of religious and mythological narratives. The application techniques used for temple polychromy required specialized skills and equipment. Paint had to be applied to stone surfaces that were properly prepared to ensure good adhesion and longevity. Multiple layers were often used to build up rich, luminous colors. Protective coatings were applied over painted surfaces to prevent weathering and fading. The timing of paint application had to be coordinated with construction schedules to ensure that painted surfaces weren't damaged by ongoing building activities. The maintenance of temple polychromy was an ongoing concern that required regular attention and periodic renewal. Painted surfaces had to be cleaned carefully to remove dirt and pollution without damaging the paint layers. Touch-up work addressed areas where paint had been damaged or had faded. Major repainting projects were undertaken periodically to restore the original appearance of temple decorations. The records maintained of these maintenance activities provide valuable information about ancient painting techniques and materials. The workshop organization required for temple painting involved teams of specialized craftsmen with different skills and responsibilities. Master painters designed color schemes and supervised overall artistic programs. Skilled painters executed detailed figural work and decorative elements. Apprentice painters prepared surfaces, mixed pigments, and performed routine painting tasks. Support workers maintained equipment, prepared materials, and handled logistical aspects of painting operations. The environmental factors affecting temple polychromy required careful consideration during both application and maintenance phases. Exposure to sunlight, rain, wind, and temperature variations could cause paint to fade, crack, or peel. The positioning of painted elements within architectural settings influenced their exposure to these environmental stresses. Protective architectural features, such as overhangs and recesses, were designed partly to shelter painted surfaces from weather damage. The economic aspects of temple polychromy represented significant investments in materials and skilled labor. The cost of precious pigments like lapis lazuli and gold made painted decoration a major expense in temple construction budgets. The time required for proper paint application extended construction schedules and required careful coordination with other building activities. The ongoing costs of maintenance and renewal of painted surfaces represented substantial long-term commitments for temple administrations. The documentation and recording of temple color schemes provided important information for understanding ancient artistic practices and religious symbolism. Written records described pigment sources, preparation techniques, and application procedures. Visual records in the form of painted pottery and other artifacts preserved examples of color combinations and decorative motifs. The systematic study of paint traces on surviving temple ruins has revolutionized understanding of ancient Greek artistic achievement and religious practice. The economic aspects of temple construction and maintenance represented a significant portion of ancient Greek civic life. The building of a major temple like the Parthenon required enormous resources and represented a massive public works project that employed hundreds of craftsmen for decades. But temples also generated income through various means. They received offerings from worshippers, fees for services, and income from lands and properties donated by wealthy citizens. Some temples operated what amounted to banking services, lending money at interest and managing investments on behalf of the city-state. The priests who served in these temples were far more than religious functionaries. They were often highly educated individuals who served as astronomers, mathematicians, physicians, and advisors to political leaders. The temple of Asclepius at Epidaurus, for instance, functioned as both a religious center and a medical facility. Patients would come from across the Greek world seeking healing, and the priests used a combination of religious ritual and practical medical knowledge to treat them. The temple complex included facilities for housing patients, areas for therapeutic treatments, and even a theater where dramatic performances were used as part of the healing process. The mystery schools associated with many temples added another layer of complexity to these sacred spaces. At Eleusis, initiates underwent secret rituals that promised spiritual transformation and understanding of divine mysteries. The physical layout of the temple complex was designed to support these rituals, with underground chambers, hidden passages, and carefully controlled lighting that created powerful psychological effects. The secrets of these mystery religions were so closely guarded that despite centuries of scholarly investigation, many details remain unknown. The relationship between temples and urban planning reflected sophisticated understanding of civic design. Temples weren't isolated structures. They were integral parts of carefully planned urban environments. The Athenian agora, for instance, was laid out so that the various temples and civic buildings created a harmonious whole that facilitated both religious observance and civic life. The positioning of temples often served as reference points for surveying and urban development, with roads and other structures aligned to create pleasing visual relationships. The maintenance of temples required specialized knowledge and skills that were passed down through generations of craftsmen. The surfaces of marble temples required regular cleaning and treatment to prevent deterioration. The metal elements needed periodic replacement or repair. The wooden components, though less common in major temples, required ongoing attention to prevent insect damage and rot. This maintenance work was typically overseen by temple officials who combined religious authority with practical expertise in construction and conservation. The festivals and ceremonies associated with temples followed complex calendars that coordinated religious observances with agricultural cycles, political events, and astronomical phenomena. The Panathenaic festival, which honored Athena, occurred every 4 years and involved elaborate processions, athletic competitions, and religious ceremonies that culminated at the Parthenon. The timing of these events was carefully calculated to coincide with favorable astronomical conditions, and the physical layout of the temple and surrounding areas was designed to accommodate the thousands of participants and spectators. The oracular functions of some temples, most famously at Delphi, involved sophisticated understanding of psychology, politics, and natural phenomena. The famous vapors that supposedly inspired the Pythia, Apollo's priestess, have been studied by modern scientists who have identified geological features that could produce psychoactive gases. But the oracular process was far more complex than simple intoxication. The priests who interpreted the Pythia's utterances were skilled in diplomacy and politics, crafting ambiguous prophecies that could be interpreted in multiple ways while maintaining the oracle's reputation for accuracy. The legal and social functions of temples extended their influence far beyond religious matters. Many temples served as places of sanctuary where individuals fleeing persecution or violence could claim protection. The right of sanctuary was carefully regulated and respected even by political authorities. Temples also served as meeting places for various civic organizations, sites for the conclusion of important contracts, and venues for the resolution of disputes. The sacred nature of these spaces lent gravity and legitimacy to secular activities conducted within them. The architectural innovations pioneered in temple construction influenced building practices throughout the ancient world and continue to impact architecture today. The development of the 3 classical orders, Doric, Ionic, and Corinthian, provided a systematic approach to proportion and decoration that has been studied and emulated for over 2,000 years. The structural principles developed for temple construction, including the use of post and lintel systems and the careful calculation of load-bearing requirements, informed the construction of other types of buildings and contributed to the overall advancement of engineering knowledge. The symbolic aspects of temple architecture conveyed complex messages about power, devotion, and cosmic order. The vertical emphasis of columns reaching toward the sky symbolized the connection between earth and heaven. The careful proportions reflected beliefs about divine harmony and mathematical perfection. The orientation of temples to cardinal directions and celestial phenomena reinforced concepts of cosmic order and the proper relationship between humans and gods. These symbolic elements were understood by ancient visitors in ways that modern tourists often miss, adding layers of meaning to the architectural experience. The craftsmen who worked on temple construction belonged to specialized guilds that jealously guarded their technical knowledge. These guilds developed sophisticated apprenticeship programs that ensured the continuation of building traditions while allowing for innovation and improvement. Master craftsmen commanded high respect and substantial compensation for their skills. The signatures and marks left by individual craftsmen on temple stones provide modern archaeologists with valuable information about construction techniques, work organization, and the social status of builders. The international influence of Greek temple design spread throughout the Mediterranean world and beyond as Greek culture expanded through trade and colonization. Local building traditions merged with Greek architectural principles to create unique regional variations. The Temple of Zeus at Agrigento in Sicily, for instance, incorporated Greek design elements with local building materials and construction techniques. These provincial temples often provide better evidence of original construction methods and decorative schemes than their more famous counterparts in Greece proper, which have suffered from centuries of renovation and restoration. The decline of traditional Greek religion didn't immediately end the influence of temple architecture. Many temples were converted to Christian churches or other uses, and their architectural principles continued to influence building design. The Byzantine Empire, centered in Constantinople, maintained many Greek architectural traditions while adapting them to new religious and cultural requirements. Later, during the Renaissance, renewed interest in classical architecture led to careful study of Greek temples and the development of neoclassical architectural styles. The rediscovery of Greek temples by European travelers and scholars in the 18th and 19th centuries sparked intense interest in classical archaeology and architecture. Early investigators often focused more on removing sculptural treasures than on understanding the buildings themselves. However, more recent archaeological work has employed sophisticated techniques to understand construction methods, original appearance, and functional aspects of temple design. Ground-penetrating radar, laser scanning, and other technologies have revealed hidden features and provided new insights into ancient building techniques. The conservation of Greek temples presents ongoing challenges that require balancing historical preservation with practical accessibility. The effects of air pollution, earthquake damage, and millions of tourists have taken their toll on these ancient structures. Modern conservation efforts employ cutting-edge materials and techniques while striving to maintain historical authenticity. The ongoing restoration of the Parthenon, for instance, involves the careful documentation of every stone, the development of new materials to replace damaged elements, and the implementation of measures to protect the structure from future deterioration. The study of Greek temples continues to reveal new secrets and challenge previous assumptions about ancient construction capabilities and religious practices. Recent discoveries include evidence of sophisticated lifting equipment, previously unknown decorative techniques, and complex relationships between different temple sites. Computer modeling and virtual reality technologies now allow researchers to recreate original appearances and test theories about construction methods in ways that were impossible for earlier generations of scholars. The influence of Greek temple design extends far beyond architecture into philosophy, mathematics, and aesthetics. The principles of proportion and harmony developed by temple architects informed Greek theories about music, poetry, and the visual arts. The mathematical relationships embedded in temple design contributed to the development of geometric theories and influenced later architectural traditions. The aesthetic principles derived from temple architecture continue to influence contemporary designers and architects who seek to create buildings that embody timeless principles of beauty and harmony. The sacred landscapes surrounding temples were as carefully planned as the buildings themselves. The approach to major temples often involved elaborate processional ways lined with smaller shrines, commemorative monuments, and auxiliary buildings. The sacred way leading to the Temple of Apollo at Delphi, for instance, was designed to create a gradual increase in spiritual intensity as pilgrims approached the main sanctuary. The positioning of trees, water features, and other landscape elements was coordinated with the architecture to create unified environments that enhanced the religious experience. The economic networks that supported temple construction and maintenance extended across the Greek world and beyond. The marble quarries of Paros supplied material for temples throughout the Aegean. Bronze foundries in various cities produced architectural elements and decorative features. Skilled craftsmen traveled from project to project, spreading techniques and stylistic innovations. The coordination of these complex supply chains required sophisticated logistical capabilities and contributed to the development of Mediterranean-wide trade networks. The educational functions of temples provided important cultural services beyond their primary religious purposes. Many temples maintained libraries, sponsored lectures and discussions, and served as centers for the transmission of traditional knowledge. The Temple of the Muses at Alexandria, though not strictly Greek, exemplified this educational role on a grand scale. Even smaller temples often maintained collections of texts, provided venues for intellectual gatherings, and supported scholars and philosophers who contributed to the advancement of learning. The technological innovations developed for temple construction had applications far beyond religious architecture. The lifting devices, measuring instruments, and construction techniques pioneered by temple builders influenced the development of military engineering, shipbuilding, and urban infrastructure. The precision required for temple construction drove improvements in mathematics, surveying, and material science that benefited society as a whole. The organizational methods developed for managing large construction projects provided models for other types of complex undertakings. The psychological and emotional impact of temple architecture was carefully calculated to inspire awe, devotion, and reflection. The scale of major temples, the quality of craftsmanship, and the integration of artistic elements created environments that overwhelmed the senses and encouraged spiritual contemplation. The interplay of light and shadow, the acoustic properties of the spaces, and the symbolic content of decorative elements all contributed to powerful emotional experiences that reinforced religious beliefs and social bonds. The regional variations in Greek temple design reflected local traditions, available materials, and specific religious requirements. The temples of Magna Graecia in southern Italy and Sicily often incorporated local building stones and adapted to different climatic conditions. The island temples of the Aegean developed distinctive features related to their maritime settings. These variations provide valuable insights into the adaptability of Greek architectural principles and the creativity of local builders working within established traditions. The ritual objects and furnishings associated with temples were as carefully crafted as the buildings themselves. Altars, offering tables, lustral basins, and other liturgical furniture were designed to complement the architecture while serving specific ceremonial functions. The positioning of these elements within the temple space was governed by religious requirements and practical considerations related to the flow of worshipers and the conduct of ceremonies. Many of these objects were works of art in their own right, created by master craftsmen using precious materials and sophisticated techniques. The relationship between temples and political power was complex and evolved over time. In the Archaic period, temples often served as symbols of civic identity and sources of legitimacy for ruling families. During the Classical period, democratic city-states used temple construction as expressions of collective achievement and civic pride. In the Hellenistic period, monarchs sponsored temple construction as demonstrations of their power and piety. These political dimensions influenced architectural choices and affected the allocation of resources for construction and maintenance. The astronomical alignments of Greek temples reflected sophisticated understanding of celestial mechanics and their religious significance. Many temples were oriented to capture specific solar or stellar events that had importance in the religious calendar. The Temple of Apollo at Base, for instance, is aligned to the rising of Arcturus, a star associated with the god. These alignments required precise surveying and long-term astronomical observation, demonstrating the advanced scientific knowledge possessed by temple architects and priests. The water management systems associated with temple complexes were marvels of ancient engineering. The sanctuary of Asclepius at Kos included elaborate aqueducts, fountains, and drainage systems that provided both practical services and ceremonial functions. Sacred springs were often incorporated into temple design, with their waters channeled through decorative fountains and basins. The therapeutic properties attributed to certain springs added another dimension to the healing functions of medical temples. The gardens and planted areas associated with temples created controlled natural environments that enhanced the spiritual atmosphere. Sacred groves provided shade and tranquility while housing trees associated with particular deities. Herb gardens at medical temples supplied plants for therapeutic preparations. Ornamental plantings created pleasant environments for contemplation and social gathering. The maintenance of these planted areas required specialized knowledge of horticulture and careful coordination with architectural elements. The workshops and studios associated with major temple complexes were centers of artistic and technological innovation. Sculptors, painters, metalworkers, and other craftsmen working on temple decoration pushed the boundaries of their respective arts while serving religious purposes. The techniques developed in these workshops influenced artistic production throughout the Greek world and contributed to the advancement of various crafts. The apprenticeship systems associated with temple workshops provided training for future generations of artists and craftsmen. The storage and security systems of temples reflected their roles as treasuries and repositories of valuable objects. Underground chambers, hidden passages, and sophisticated locking mechanisms protected precious offerings and civic funds from theft and damage. The Temple of Artemis at Ephesus, one of the 7 wonders of the ancient world, included elaborate security features that protected its enormous wealth from numerous threats. These security systems represented significant engineering achievements in their own right. The lighting systems of temples created dramatic effects that enhanced religious ceremonies. Carefully positioned windows and skylights controlled the entry of natural light to create specific atmospheres at different times of day and year. Artificial lighting using oil lamps and torches was coordinated with architectural features to create impressive visual effects during evening ceremonies. The interplay of light and architectural elements was as carefully choreographed as the religious rituals themselves. The acoustic design of temples extended beyond simple sound transmission to include the creation of specific auditory experiences. The reverberation characteristics of different temple spaces were tailored to the types of ceremonies conducted within them. Spaces used for choral performances had different acoustic properties from those designed for spoken rituals. Some temples included acoustic features that created unusual sound effects, such as whispering galleries or chambers where sound was mysteriously amplified or distorted. The ventilation systems of temples addressed both practical and ceremonial needs. Underground chambers required carefully designed airflow to prevent humidity problems and ensure the preservation of stored materials. The burning of incense and sacrificial offerings created smoke that needed to be managed to maintain comfortable conditions for worshippers. Some temples incorporated chimney-like features that channeled smoke in specific directions for dramatic effect during ceremonies. The measurement and surveying techniques used in temple construction achieved remarkable precision using relatively simple tools. Ancient architects developed sophisticated methods for ensuring that foundations were level, walls were plumb, and proportions were accurate. The units of measurement used were carefully standardized and coordinated across different crafts to ensure that architectural elements fit together properly. These measurement systems influenced construction practices throughout the ancient world. The transportation networks that supported temple construction required significant infrastructure development. Roads had to be built or improved to handle the movement of heavy materials. Harbors and docking facilities were needed for sites accessible by water. Temporary railways and lifting systems were constructed to move materials from transportation points to construction sites. These infrastructure improvements often had lasting benefits for the communities involved in temple construction. The social organization of temple construction projects provided models for other large-scale undertakings. The coordination of different crafts, the management of supply chains, and the supervision of large workforces required sophisticated administrative systems. The records kept by temple construction managers provide valuable insights into ancient project management techniques and labor organization. These systems influenced the development of other types of complex organizations in ancient society. The symbolic programs incorporated into temple decoration conveyed complex theological and philosophical concepts through visual means. The sculptural narratives that adorned temple facades told stories that reinforced religious beliefs while providing moral instruction. The mathematical relationships embedded in architectural proportions reflected concepts of cosmic harmony and divine order. These symbolic elements were designed to be understood at multiple levels, providing simple visual pleasure for casual observers while offering deeper meaning to those with appropriate knowledge. The maintenance traditions associated with temples ensured their survival over many centuries. Regular cleaning, repair, and renovation work was organized according to established schedules and procedures. Specialized craftsmen were trained to work with particular materials and architectural elements. The funding for maintenance work was provided through various sources, including temple revenues, civic appropriations, and private donations. These maintenance systems represented significant investments in the preservation of cultural heritage. The international pilgrimage networks that developed around major temples created cultural and economic connections across the ancient world. Pilgrims traveling to famous oracles, healing centers, and festival sites brought news, ideas, and economic benefits to temple communities. The accommodations, services, and amenities provided for pilgrims became significant industries in their own right. These pilgrimage networks facilitated the spread of architectural styles, artistic techniques, and religious practices across cultural boundaries. The legal frameworks governing temples addressed questions of ownership, management, and public access. Sacred laws specified the rights and responsibilities of priests, worshippers, and civic authorities. Property rights in temple lands and buildings were carefully defined and protected. The legal status of temple treasuries and their relationship to civic finances were regulated by detailed statutes. These legal systems provided stability and continuity for temple operations over many generations. The environmental considerations incorporated into temple design reflected understanding of local climate, geology, and natural phenomena. The orientation of buildings took account of prevailing winds, seasonal weather patterns, and the movement of the sun throughout the year. Drainage systems were designed to handle local rainfall patterns and prevent water damage. The choice of building materials considered their durability in specific environmental conditions. These environmental factors influenced architectural choices and contributed to the longevity of temple structures. As our journey through the secrets of ancient Greek temples draws to a close, we find ourselves with a profound appreciation for the complexity and sophistication of these remarkable structures. They were far more than simple buildings. They were the product of advanced mathematical knowledge, sophisticated engineering skills, deep religious understanding, and artistic genius. From the hidden treasuries beneath their floors to the astronomical alignments of their walls, from the acoustic perfection of their interiors to the symbolic meanings embedded in every decorative element, these temples represented the highest achievements of Greek civilization. The legacy of Greek temple architecture extends far beyond the ancient world into our modern era. The principles of proportion, harmony, and mathematical precision developed by Greek architects continue to influence building design today. The integration of functional and aesthetic considerations pioneered in temple construction remains a fundamental goal of contemporary architecture. The sophisticated understanding of materials, structural systems, and environmental factors demonstrated in ancient temples provides valuable lessons for modern builders facing similar challenges. The technological innovations developed for temple construction contributed to advances in many other fields of human endeavor. The mathematical techniques used for calculating proportions and alignments influenced the development of geometry and trigonometry. The engineering solutions developed for moving and placing massive stone blocks contributed to advances in mechanical engineering and construction technology. The organizational methods used for managing complex construction projects provided models for other types of large-scale undertakings. The cultural impact of Greek temples extends beyond their architectural significance to encompass their roles as centers of learning, artistic production, and social organization. The libraries and schools associated with temples preserved and transmitted knowledge across generations. The workshops where temple decorations were created fostered artistic innovation and technical advancement. The religious and civic activities centered on temples strengthened social bonds and cultural identity within Greek communities. The archaeological investigation of Greek temples continues to reveal new secrets and challenge previous assumptions about ancient capabilities and achievements. Modern scientific techniques, including ground-penetrating radar, laser scanning, and computer modeling, have uncovered hidden features and provided new insights into construction methods and original appearance. The ongoing study of temple ruins contributes to our understanding not only of ancient architecture, but also of the societies that created these magnificent structures. The conservation challenges facing ancient Greek temples in the modern world require innovative approaches that balance historical preservation with contemporary needs. Air pollution, climate change, and tourism pressure threaten the survival of these irreplaceable monuments. The development of new conservation techniques and materials draws on both ancient wisdom and modern science to ensure that future generations can continue to learn from and be inspired by these architectural masterpieces. The educational value of Greek temples extends to multiple disciplines, including architecture, engineering, history, archaeology, art history, and religious studies. The interdisciplinary nature of temple studies encourages collaborative research that breaks down traditional academic boundaries. The lessons learned from studying ancient temples inform contemporary practice in fields ranging from structural engineering to urban planning to cultural preservation. The symbolic and spiritual significance of Greek temples continues to resonate with people around the world, regardless of their religious beliefs or cultural backgrounds. The temples represent humanity's eternal quest to create beauty, meaning, and connection with something greater than ourselves. The mathematical harmonies embedded in their design speak to universal principles of order and proportion that transcend cultural and temporal boundaries. The craftsmanship evident in every detail demonstrates the human capacity for excellence and dedication to transcendent ideals. The international influence of Greek temple architecture spread throughout the ancient world and continues to shape building design in the modern era. From the Roman adoption and adaptation of Greek architectural principles to the neoclassical revival movements of the 18th and 19th centuries, the influence of Greek temples can be traced through 2 millennia of architectural history. Contemporary architects continue to draw inspiration from the timeless principles embodied in these ancient structures. The economic lessons embedded in Greek temple construction provide insights into the relationship between public investment, skilled craftsmanship, and long-term value creation. The resources devoted to temple construction represented significant public investments that provided employment, fostered technological advancement, and created lasting monuments that continued to generate economic and cultural benefits for centuries. The model of public-private cooperation in temple funding and construction offers relevant examples for contemporary infrastructure and cultural projects. The social organization required for temple construction demonstrates the human capacity for cooperation and coordination in pursuit of shared goals. The successful completion of major temple projects required the collaboration of hundreds or thousands of individuals with diverse skills and backgrounds. The systems developed for managing these complex undertakings provide insights into leadership, organization, and project management that remain relevant today. The craftsmen who built them, the priests who served in them, and the pilgrims who visited them were all part of a cultural tradition that continues to influence our world today. The secrets we have explored tonight remind us that the ancient Greeks were not primitive people building simple structures, but sophisticated architects and engineers whose understanding of mathematics, astronomy, acoustics, and human psychology allowed them to create buildings that have inspired awe for over 2,000 years. As you drift off to sleep, imagine yourself walking through the marble halls of the Parthenon, feeling the cool stone beneath your feet and sensing the presence of the countless generations who found meaning, hope, and wonder within these sacred spaces. And may your dreams be filled with the timeless beauty of these architectural marvels that continue to guard their secrets even today. Good night.